Okay, so there are four advanced techniques of integration, and we'll be discussing them um, by topics. So we'll be starting off with algebraic substitution. So I think more of the advanced topics are just advanced techniques in substitution. So we have the regular U sub technique or the sub technique, but this particular um, advanced topics or advanced method of substitution requires more process compared to the last one. But most of it are just similar compared with the U sub technique. Okay, so we have algebraic substitution, trigonometric substitution, integration by parts, and integration by partial fraction. So let's start. So let's start with algebraic substitution. So if you're going to read the description, so I think most of this is the same as your U sub technique. So we have to introduce a new variable of integration in place of the original. So I think this one is more likely a description of your U sub, but I think what is lacking here is I think you need to replace or you need to substitute the difficult term. So replacing or so the difficult term. So most likely these are the radical expressions, the binomial. So most likely we're going to deal with radical expressions in algebraic substitution. Okay, so of course your sub technique is most likely determined by inspection of the integrand, and again it's more of a trial and error method as the same as your U sub technique. So a trial and error method. Okay, so again there are no rules as long as we can replace every term in the integrand, so we can use the sub technique, and of course you can only achieve this with practice. So that's why after every topic I give you 10 problems to solve. Okay, so I think the most important tip here is again the same as your U sub. So replace the difficult term. Alright, so let's try to solve 7 problems for today's session. Okay, so as you can see, we are dealing with radicals, and I don't think that you can easily use U sub here for you to be able to solve the following integrals. So that's why you need to use algebraic substitution. Okay, so let's start with the first example. So we have the integral of square root of x dx all over 1 plus x. So again, if you're going to use simple U sub, so let's say U sub, so let's say u is equal to square root of x. So derivative of this one is du is equal to 1/2 x to the power of negative 1/2 dx. So as you can see, this term here is not present in the given integrand above, and we still have a remaining term to be replaced, which is 1 plus x. So let's try if our u is equal to 1 plus x. So du is equal to dx. So notice that the remaining term, if we're going to use this particular U sub, the remaining term is square root of x. Earlier, the remaining term for the first U sub is 1 plus x. So again, the aim of your sub technique is for you to be able to replace every term in your integrand. So meaning either way, So either way of your u sub technique, so we cannot utilize either way because we cannot replace every term in your equation. So that's where the advanced technique comes in. So that's why we apply algebraic substitution. So again, the tip here in algebraic substitution is for you to replace the complicated term with with another variable. Okay, so again, this one is x. So let's try to erase this one first. Okay, so again, the tip is to replace your complicated term with another variable. So usually in algebraic substitution technique, we introduce a variable called z instead of u. So instead of u sub, so we call the algebraic substitution as the z sub technique. So introducing the z variable now. Okay, so z, and then we replace the complicated term, which is the radical expression, which is square root of x. So z is equal to square root of x. So of course, for us to be able to um, deal with the expressions later in an easy manner, so we need to eliminate the radical symbol or the square root symbol. So in doing that, we square both sides. So we have z squared is equal to x, right? So since we have eliminated your square root, so we can now get the derivative. So derivative of 2z squared, I mean your z squared is 2z dz. And on the right side, that's dx. Okay, so notice that we can replace your square root of x with z. We can replace dx with this term here. And we can replace your x term with z squared. So kanang constant, okay na constant because it won't deal much with the equation later. As long as we replace every variable with another variable. So from x to z, from let's say in our u sub technique, from x to u variable. So that's the aim of your sub technique. Okay, so if we try to replace every term here, so in the numerator, square root of x becomes z. Then your dx is now 2z dz. So divided by 1 plus z squared. So notice in the new integrand, we won't be dealing with radical expressions anymore. Okay. So further simplifying is we have integral of 2z squared dz all over 1 plus z squared. Then bringing the constant outside the integral symbol, we have z squared all over 1 plus z squared dz. So what do you need to do next is, of course, since this one has an equal power, so this one is squared, this one is squared, so that means we can use long division for us to be able to further simplify this term. So let's try another color so that we can notice the division, the process of division on the right side. So this is the divisor, this is the dividend. So 1 plus z squared divided by z squared. So you have 1. So z squared plus 1, then minus. So the remainder is negative 1. So again, if you don't know how to write the remainder, so that's the answer, the quotient, plus the remainder over the divisor. So minus 1 all over 1 plus z squared. So that's how you write your quotient plus the remainder. So in case you forgot how to write the remainder. So that's the remainder all over the divisor. Okay, so instead of having this one, so we have 2 integral of 1 minus 1 plus z squared dz. So if we try to separate this one, so let's try separating it because I think the second term is a complicated integral, or if you don't notice, basta mura siya complicated. So you have 1 plus z squared dz. So in the first integral, so I think this one is just an easy integral, basic integral. So in the second one, you have integral of 1 all over 1 plus z squared. So if you remember this format, so this format is more likely the inverse trig function, right? A squared plus u squared. So automatically this one becomes 2 times arctangent z plus c, right? So of course there's no 1 over a because your a squared is just 1 and a is still 1. So that's why there's no 1 over a anymore. So ako lang siyang i-shortcut. So of course, don't forget to bring back the value of your z parameter. So you have so 2 square root of x minus 2 arctangent square root of x plus c. So this one is your final answer. Okay, so do you have questions or clarifications? Okay, so I think you have no questions. So let's try to move on to the next example. So this time is we have integral of dx all over x minus square root of x. So as you can see, the given expression cannot be simply solved using the u sub technique. Because if you let the denominator be the u, so we have to go through another process of a difficult derivative, diba? So for example, we let u is equal to x minus square root of x, diba? So du is equal to dx, and then this one is minus 1/2 x to the power of negative 1/2. Diba? Dx, and murag, it's a difficult expression compared to the kuan, diba? Mas difficult siya samot instead of making it an easy expression. Okay, so again, if the expression cannot be solved simply by the use of technique, so that's why we introduce another advanced technique, which is the algebraic substitution. So again, we're going to use z sub now, z sub. So again, complicated term, so x again square root of x. So I think the complicated expression is the square root of x. Okay, so getting rid of the radical symbol, so squaring both sides, so we have z squared is equal to x, and then getting its derivative, so we have 2z dz is equal to dx. So notice that this term is your square root of x. We can replace that one with z. Your x can be replaced by z squared. And then your numerator, the dx, can be replaced by 2z dz. So if you're going to rewrite the equation through the algebraic substitution technique, so this becomes 2z dz. So divided by the square root of, so that the x is now z squared, then minus z. Okay, so factoring out 2 outside the equation, so we now have z dz all over z squared minus z. So comparing it with the original equation, so I think this one is more workable compared with the radical expression. Okay, so I think we can still simplify the term earlier. So in the denominator, so we can factor out 1z. So z dz all over z, then we have z minus 1. Then cancel out z, so the remaining expression is now 2 integral of dz all over z minus 1. So I think in this particular term or the equation can now be solved using u sub, diba? So even though it's a simple ln integral, so let's just verify if it's really the u sub technique, Jud. If it agrees with the u sub technique, so z minus 1 and then du is equal to dz. So this one is u and then this one is your du. Okay, so you now have 2 integral of du all over u. So the answer is 2 ln u plus c. So bringing back the value of the u parameter, that's z minus 1 plus c. So bringing back the value of z, that's square root of x. 2 ln square root of x minus 1 plus c. So mo ni siya. So this is your final answer. So I think if you're going to ask me what's the difference between u sub and your algebraic sub, so I think the u sub is the aim of your u sub is for you to be able to reach the basic integrals or the basic formulas for your integrals. Now, on the other hand, the aim of your algebraic substitution is for you to simplify first the given integrand. So from a complicated expression, going down to a much easier form of the integrand. So both are achieving a simple um, format, but I think in algebraic sub it's a bit more complicated. It's more complicated compared with the u sub process. Right, so I think that's the difference between the two, because in your algebraic sub you can still incorporate u sub, but in u sub you only have to use u sub to be able to reach the easier format or the basic format. Algebraic sub is you have to use algebraic sub first, then maybe sometime later in the process you have to use u sub again for your expression to be more simpler. Okay, so questions or clarifications? Okay, so I think you don't have questions. Okay, so let's proceed. Okay, so we now have this example. So we have the integral of a x cube times the square root of x minus 4. So again, if you're going to use u sub, let's say x cube ang atong u, then the du is 2x squared. So notice that there's no x squared present in the equation. Okay, so we cannot use this particular u sub. So let's try expressing it with another term. So x minus 4 baron. So du is equal to dx. So notice that we can replace this one with u, we can replace this one with du, but there's an x cube left in the expression. So di gyapon, di ba? So let's try u na sad na lain na sad. So square na. Then if you're going to get du, so marag 1/2 x minus 4 raised to the negative 1/2 dx. So it becomes even more complicated, diba? So we cannot use this one also. So going to your algebraic sub technique. So again, we're going to let, or I think if there's a radical expression, the aim of your algebraic sub is to eliminate the radical term. So for example, this one z, then automatically this becomes square root of x minus 4. So eliminating the alright, so next is we're going to eliminate your radical term. So this becomes x minus 4. Okay, so getting the derivative, oops, it's so 2z dz, then we have your dx. Okay, so take note that we can replace the term here, x cubed with z. Your dx is now 2z dz. So how about x cubed? So notice here is we can isolate your x. So you have z squared plus 4 is equal to x. Then of course getting the cube. So we have z squared plus 4 cube is equal to x cube. So we can replace this term also. So again, there's nothing left to be replaced in the given integrand. So everything can be converted into the z variable. So this becomes integral of, so first is x cubed, so this one is z squared plus 4 cube. Then your square root of x minus 4 is now your z, so times z. Then your dx is 2z dz. Okay, so simplifying further, so you have z squared plus 4, then times 2z squared dz. So if we're going to look at the expression, so I think it's easier to calculate or to go through the process now because I think it's just simple algebra. So we have a cube binomial, diba? So Okay, so if we try to simplify it further, so we have z squared plus 4 cubed, then z squared dz. So I factored out the constant outside. So notice that we can expand this one and then distribute z squared to each term inside the expression. So again, if you don't know the shortcut, so murang ang shortcut ani is katumang kuan, di ba? Pascal's triangle. So 1, 1, 1, then 1, 2, 1, 1, 3, 3, 1, di ba? O na siya, di ba? So first is you have z to the power of 6 then plus, so cube na sad ta, so plus 12 z to the power of, unsa naman siya, wala mo nagalisod sad ko. Sige, para di ta maglibog ato lang siyang i-basic jud kay hindi mo ganag Pascal's triangle. So ato lang siyang anaman na muna. So if binomial z squared plus 4, so z squared plus 8 z to the power 4 ni siya, 8 z squared plus 16, di ba? Then multiply na sa taglayan na kuan z squared plus 4. So let's multiply first the first term. So z to the power of 6 plus 8z to the power of 4 plus 16 z squared. Then the second term is 4z to the power 4 plus 24z squared plus 64. Okay. So combining the terms, you have z squared plus 12z to the power of 4 plus kani siya is mahimo ni siyang pila man ni 40 z squared plus 64 na. So correct me if I'm wrong, muna siyang kon 24z squared nya na may 6 32 din eh. So kani siya instead of, so kani siya mga 48, no? So kana sakto na. Sakto na, no? So we have 12z to the power of 4 plus 48 z squared plus 64. So let's try to erase. Okay, then we have z squared dz. So distributing your z squared to each term inside the polynomial. So this becomes z to the power of 8 plus 12z to the power of 6 plus 48z to the power of 4 plus 64z squared dz. So again, if we try to integrate each term, so this one is a basic formula, exponent rule. So 2z9 all over 9, diba? Mawala na siya. Plus 24 z7 over 7 plus So that's, I think this one is 96 z to the fifth over 5. Then this is 124 z cubed all over 3 plus c. So bringing back the value of the z parameter, so you now have, so I think you can write it in this manner. So 2 over 9, and then ato lang siyang ikuan, ato lang siyang i-exponent term para dito maglibog sa exponent na 9. So instead of square root of square root of x minus 4, so x minus 4, then 9 halves. Right? I think this one is still correct, because I think it's difficult to write if you're going to have this in this expression. So x minus 4, then to the power of 9. Diba? Maragdaghan na kayo mas taas siya tanawon kay tungod sa radical expression. But pwede rin po siya ana. Ako rin po siya dawaton. Sige ato yung side by side. So 24 all over 7. Then x minus 4, 7 halves, plus 96 over 5, x minus 4, 5 halves. Then lastly is 124 over 3, x minus 4, 3 halves plus c. So kana pwede rin na siya nga answer. Or kani pwede po siya ani nga pag-answer kaning radical expression sa gyapon. O di mo ganahan atong pina-exponent na kuan expression na. Pwede siya inani sa DOPS. Na pwede sa rin yung inani sa na to the power of 7 na pwede sa siya. Whichever suits your taste sa pag-express sa kuan. So x minus 4 to the power of 5, then plus 124 all over 3 square root of x minus 4 cube plus c na. So depende niyo sa niyo pag sa ganahan ninyong style of expressing the final answer. Alright, so do you have questions? So I think this one is, you can verify this one in the symbol lab, but I think my method is different compared with symbol lab, but the final answer is the same, I guess. So try verifying it lang in symbol lab. Alright, so do you have questions? Okay, so none. So let's proceed with the next example. Okay, so this time is we have the fifth root of integral of x, fifth root of x plus 1 squared dx. So again, the aim is to eliminate the radical expression. So z is equivalent to the fifth root of x plus 1 squared dx. Alright? So, di siya dx day. Kaya nag-sub technique na ta. Okay, so in exponential expression, so this becomes 2/5, diba? 2/5. And then you're so multiplying to eliminate the radical expression. So we're going to have z to the power of 5 is equivalent to x plus 1 squared. So muna siya inyong kuan. Okay, so itong tanaw na kung tanaw kong libro ka dito. Okay, so sayop din ni siya kung pagsuwat sa kuanday. So ako sa erase na. So kaning 5 di ay should be the exponent of x. Kuan di siya dapat di ay. X to the power of 5 then square root of x plus 1 squared dx. So mo din siya ang correct. Mo din may buong ko nga kuan, may mo siyang radical expression gyapon ang z. Okay, so let's try again. So z is equal to square root of x plus 1 squared. So this becomes z squared is equal to x plus 1 squared. So next is we're going to have, so this one is, so common na siya, we have 2z dz, then this one is 2 times x plus 1, then dx. Okay? So sakto ba? So notice that murag dili mo ato ang dx, no? So let's try to manipulate even further. Ano man yung example, ah? Save mo din ako pagkuhan. Okay, so let's try to kuhan sa edit, ha? Sila, mapakita yung pagi. Sige. Okay, so murag safety ko dai. So sakto din ning akuan, wag nalibat naman ko eh. So sakto din ning ang term, but ang buhat na ani is again trying the z sub. So let's say fifth root of x plus 1 squared. Diba? Then getting the, so if you're going to let this one in exponential form, so this one is x plus 1, 5 halves. Dire 2 fifths there, 2 fifths. So for us to eliminate the expression, so we're going to multiply by 5 halves there. Dilita mo ko anday. So multiplying by 5 halves to eliminate completely. So 5 halves is equal to x plus 1. Okay. So getting the dz for this one, for us to be able to get dx. So 5 halves z, then minus 1. This becomes pila may 3 halves, no? Sakto ba? dz is equal to dx. So this one can be replaced by the c term. This one can be replaced by this one. So how about x to the fifth? So dire is we have z to the power of 5 halves. So minus 1 is equal to x. Then to the power of 5, so this one is z 5 halves minus 1 to the power of 5. Then x to the power of 5. So let's try if sakto atong ibuhat. So again, most likely ang ato ang process is more of a trial and error method. So murag dili siya perfect nga in one go we can easily answer the equation. So maskin ako masayop-sayop sa ko sa kay makalimot sad ko. So let's try if sakto niya akong ibuhat. So the first one is z 5 halves minus 1 to the power of 5. Then next one is z. Then dx is 5 halves z 3 halves dz. Na. So murag mas ni complicate siya, di ba? So 5 halves is z 5 halves minus 1 to the power of 5. And then z 5 halves dz. So looking at your expression, so instead of getting an easier format, so murag mas ni lisod siya, di ba? So murag dili mao to ang process. So muna, let's try another method na sad. So ato lang siyang i-green lang ana. So ato lang suway-suwayan kung makakuha ta answer. So let's try if ato ang ikuan lang sa kay x plus 1 ana. Let's go very basic ana. Suway-suway lang ta. And then your z, I mean your x, if we try to isolate your x, so that's z minus 1 is equal to x. Then getting the derivative, we have dz is equal to dx. Ana, marag pwede siya, no? So let's try. So ato lang i-green gyapon. So the first term is now z minus 1 to the power of 5. Dito siya to the power of 5, murag. Ang root din na siya. And then square root, fifth root fifth root of, so x plus 1 is now z. So z squared na, di ba? Murag mas nisayon siya, no? Then dz is just dx. So na. So we now have z minus 1, then z to the power of 2 fifths dz. So murag mas masayon siya compared earlier because we can distribute this one inside the parenthesis. So another kuanday, so murag another kanang discovery is that instead of just putting the radical expression inside the z term, so muna di ba more trial and error siya, whichever suits your kuan, murag whichever process nga maka-reach mo easier expression. So dire is since naka-reach mo tag easier expression compared sa kaning ganina, na kani. So murag mas maayo nga kanina po dato ang gamiton, di ba? Dili siya radical expression but of course, along the process, we have eliminated the radical expression, not totally eliminating it, but making it more simpler. So this becomes z to the power of 7/5, di ba? Minus z to the 2/5 dz. So integrating, so murag mahugsad kaya ang not so murag mahugsad na inyong algebraic substitution is not only exclusive to radical expression but to any format, as long as you once you make the algebraic sub technique, you'll be able to reach a simpler format. So murag mo na siyang new discovery. So kana new discovery po na siya nako kay nagtuo ko nga puro radical expression ang algebraic sub. Alright, so this one is plus 1. So that's z 12 na nino, 12/5 12/5 minus z 7/5 all over 7/5 plus c. So this becomes 5z 12/5 over 12 minus 5z 7/5 over 7 plus c. So again, bringing back the value of your z parameter. So 5x plus 1, 12/5 over 12 minus 5x plus 1, 7/5 over 7 plus c. So try to kung ano siya, to recall lang ni nga example kay manag it's not perfectly discussed kay makalimot sad ko na kay usually magud ka nang mag-discuss ko integral calculus na murag every year ko maka-discuss balik kay ini ka next sem kay wala may calculus next sem na ini ka magkwata sa go ini ka next year na sad na. So say malimtan ako nga mo din siya nga process na. Okay, so just try to verify the answers in Symbolab. So I think it's correct man siguro. Basta ang new discovery na to day, or akong, let's say, di siya new discovery, or basta nalimtan lang ako og ingon ganina. So aside of replacing radical expression, so you can freely explore the algebraic sub as long as you get, or you reach an easier format or a simpler format from the original equation. So again, comparing the z sub nga atong igamit ganina, comparing with another z sub kani, di ba? So marag masayon ni siya compared ani. So again, just try to marag freely explore the examples later. So let's say katong examples 1 to 3 nga akong i-discuss ganina. So try manipulating the z sub technique if you're able to reach another simpler format. So if not, so meaning ato kato akong ibuhat is mo to ang pinaka-simple na. Alright. Okay, so let's go to this example. So integral of x dx all over cube root of x plus 1. Okay, so if we're going to let z, so let's try different methods. So let's say x plus 1 ba na. So let's try not eliminating first the radical expression. Ato tanaw nung unsay gawas. Okay, so if you isolate your x variable, because we have an x variable in the numerator, so that's z minus 1 is equal to x, and then there I'm getting the derivative, that's dz is equal to dx. So replacing the equation, so let's try kuha na ato lang side by side ni tanan. So that's z minus 1 from the x variable in the numerator. So instead of, so this one is dx there. So dz, so all over cube root of x plus 1. So this one becomes cube root of z. Na, so let's say muna siya ito ang final format. Diba? So let's try another z sub na sana na as what I have mentioned earlier. So atong suway-suway ang tanan. So let's say z is the cube root of x plus 1 ana karon ana nasad. And then getting the cube, so you have z cube is equal to x plus 1. So again, since we have an x variable in the numerator, so isolating your x first. So si x, i-isolate si x. Na, di ba? Then we get the derivative. So getting the derivative, that's 3z squared. So minus 1, that's 0. So dz is equal to dx. Na. So getting the format, the new format, so x is z cubed minus 1. Then dx is 3z squared dz all over z. So this one can still be simplified because the denominator and the numerator can be cancelled by 1z. Sakto, di ba? So the expression is much more simpler. Z cubed minus 1, then 3z dz. Then further simplifying is we have z cube minus 1 times z dz. Yeah, must simplify pa dyan siya even further. Z to the power of 4 minus z dz. Na, diba? So comparing the left, the blue z sub and the green sub, and then the green z sub. So I think if you look at the final format, so murag masayon i-integrate ang green, di ba? Na z sub compared sa inyong blue nga z sub, because in the blue z sub you still have a radical expression in the denominator. Diri sa ato ang kuan z sub nga green, so most likely automatic magamit nato dito og kanang exponential rule, di ba, katong basic formula. So meaning is we can't utilize this one because it's difficult. So arito dire. So again, most likely your sub techniques are more of a trial and error method. Murag inyo ra siyang i-discover freely jud. So it's a okay, so this one is 3, then z to the 5th over 5, diba? Minus 3z squared all over 2 plus c. So again, don't forget to bring back the value of your z parameter. So 3, so since this one is cube root, so again, murag the same nga pang kanina, so depende sa inyong style on how you want to express your radical expression. So if you want to express this in square root, so pwede ra gyapon in roots, na pwede gyapon siya. Na pwede niya pag-express minus 3, then cube root of x plus 1 to the power of 2 over 2 plus c. Or if pina-exponential expression, kana exponent, puro exponent ba? So x plus 1, then 5/3 all over 5, then 3x plus 1 to the power of 2/3 over 2 plus c. So this one is minus the so makita nyo ang difference, no, sa pag-apply sa z-sub. So again, it could be any other method depending on basta ang ultimate ninyong i-achieve is a simpler version of the equation jud. So as what we did here in example number 5, so we tried using the technique from the previous example nga wala to gi z-sub ang radical expression, but first is we took the binomial first as your z. And then we tried another z-sub, which is the radical expression. So the radical expression nga z-sub is what made us reach a simpler equation man. So mana. So kung maingon na jud is you have to explore jud the techniques. Pero as per experience, so most likely ang inyong easy sub is katod yung radical expression as per ko na experience nako. Okay. So let's go to the next example. So we have the integral of z cube, x cube. Z yung tag z ani. So x cube all over cube root of x squared plus 4. So again, let's try to use different techniques. So let's try to without the radical expression first. So let's try this one. Diba? So let's try this one. And then next is if you try to isolate your x parameter, so that's z minus 4 is equal to x squared. So notice in the numerator, natay x parameter, di ba? Yeah, medyo maglisod ta because this one, the numerator is x cubed and what we have here is only x squared. Diba? So maglisod ta. So let's try lang sa gyapon. So getting the derivative of this one is dz minus 0, di ba? Is equal to 2x dx na, di ba? So let's try another method na sad na. So atong side by side ito para makita ang kaan. So if z is equal to the cube root of x squared plus 4, by getting the cube, that's z cube is equal to x squared plus 4, diba? Then getting the derivative, so we're going to, before getting the derivative, so let's try to eliminate first the x, isolate the x, so z cube minus 4, that's x squared. So getting the derivative, that's 3z squared dz is equal to 2x dx. So notice nga both have achieved the 2x dx, diba? This one here. And the one here on the left is 2x dx gyapon. But on the left side we have dz. On the right side is we have 3z squared dz. So let's try to Quant even further. So this one in the numerator, so I think we can express this one as x squared and then x dx, diba? Kaya since we have an x dx here, diba? So this becomes dz over 2, then x dx, na, diba? So meaning if we try to use this one first, so x squared is your z minus 4, then x dx is dz all over 2, divided by the cube root of z. So notice, nagapoy z diyan, nagapoy kanang kuan ba? Nagapoy siya kanang radical expression. So medyo lisod siya i-deal with. So on the right side, so let's try on the right side if this one is a bit simpler compared sa kaning green one. Oops, more lighter ang blue da. Okay, so x squared is z cubed minus 4. Diba? Then x dx is 3 halves. So again, this one becomes 3 halves z squared dz is equal to x dx. So 3 halves z squared dz. Then divided by, kung tanawan niyo, ang atong cube root of x squared plus 4 becomes the z now. So getting 1z out, so the expression is now z cubed minus 4, then 3 halves z dz. So notice comparing this one here against this term here, so kani siya still complicated, di ba? This one is a bit murag simpler na compared earlier. So again, from the two z sub techniques, so I think this one is better, di ba? So analyzing it even further, so factoring out the constant. So we now have z cubed minus 4, and then z dz. So 3 halves, and then we have z to the power 4, then 4z dz. So 3 halves times z to the 5th over 5 minus, so this becomes 6z squared all over 2 plus c. So 3z to the power 5 all over 10 minus 3z squared plus c. So bringing back the value of the z parameter. So I like the expressions being expressed in exponential form para di ko magsigswa to radical expression. So 3, then x squared plus 4, 5/3 minus, so over 10 is siya. Over, so one eye space. Then minus 3 x squared plus 4, diba? 2/3 plus c. So muna siya ang final answer. Alright. So do you have questions? So I think murag wala no kay libog. So mas libog ang final na example. Okay, so 1 integral of 1 all over square root of x plus cube root of x. So tanaw nimo murag puro siya square root no. So again, if we have square roots nga term, yeah, there's no x variable. So I think the best method here is for you to eliminate the two radical expressions in one go. Diba? So again, if we try to let's say, z is equal to cube root of x, then getting the cube, that's z cube is equal to x, diba? So we eliminated this term here. So how about for square root of x? Diba? Ma-eliminate ang other cube root, but ang square root is dili siya ma-eliminate. So again, the best advice here is for you to eliminate both in one go. Both radical expressions in one go. So doing that, so again, if we try to, so ato ning ipakita jud. Now, so let's try if our z is square root of x po, di ba? So we have z squared is equal to x. So we have eliminated the square root of x, but we still have cube root of x, which we cannot manipulate anymore the equation because we're only limited with these terms, diba? We cannot generate cube root out of these terms here. Also earlier, we cannot generate square root of x from cube root. Diba? Murag lisod siya ikuan. So again, murag we need to visualize on how we eliminate both expressions in one go. Diba? So in doing so, I think the best way is for you to represent one radical expression that can eliminate both the cube root and the square root. So, unsay pasabot ako ana, so z is equal to the 6th root, di ba? Of x na. So, let's try ana, 6th root pa ron, di ba? So, in doing so is if we have z to the power of 6 and this one is equal to x. So notice that if we plug in the value of x inside the square root, that's z to the power of 6. So now may square root ang z to the power of 6, di ba? And that's z cube. Diba? So if we try to replace your x within the square root, so z to the power of 6, this one becomes z cube, di ba? And ang isa, if we have cube root of z to the power of 6, this one becomes z squared. So sakto, di ba? So earlier, if we try to plug in, so let's try to change colors para ma-understand you better. So earlier, if our z is cube root of x only, so if we try to plug in your square root of x so we're going to have in the term square root of z cube plus z, di ba? So we still have a radical expression here, which cannot be simplified anymore. On the right side, katong sa green, so if we try to replace it with z, so this one is z now. Then we have cube root of x squared, di ba? So I mean z squared. So murag nagyapon tay radical expression, di ba? Murag again the aim is to make our expressions more simpler. So in the red one, kaning red one, so since we let your z be equal to 6th root of x, and then we eliminate the terms in the denominator. So what it looks like now, it's 1 all over z cube all over z squared, di ba? So kato yung dx. So of course, for us to be able to get dx, so get the derivative. So 6z to the power of 5 dz is equal to dx. So times 6z to the power of 5 dz. So 6 integral of z to the power of 5 dz, then z cubed plus z squared. So notice that this term here is more simpler or easy to deal with compared with this one. Kani siya. Ang atong gitry-try, di ba? So calculating even further, so we can factor out z squared here. This becomes z plus 1. So cancel out z squared. So we have 6 z cubed dz all over z plus 1. So I think in this term here is we can use the long division. Okay, so using the long division, so let's try another color for you to be able to see the long division method. So again, we can use long division of the algebraic expressions because the numerator is of higher degree in the denominator. So third degree against the first degree equation. Okay, so z plus 1, then z cubed. So z squared first. So z cubed minus z squared plus z squared. So we have negative z squared, then minus z. So we have negative z squared minus z. So plus z na sad ta. Then plus 1. So z plus 1 is negative 1. So ako lang i-shortcut. So again, if you want to write this one in the correct form, so quotient z squared minus z plus 1, then the remainder all over the divisor, so minus 1 all over z plus 1. So the expression becomes 6 integral of z squared minus z plus 1 minus 1 all over z plus 1 dz. So integrating is we have 6z cubed all over 3 minus 6z squared over 2 plus 6z plus minus tayo minus 6 ln of z plus 1 plus c. So simplifying, so maragwan tayo space, no? So let's try to erase some lang sa. So kanila ko erase sa kaning green. So just try to review the recording later para nice space. Okay, so 6 over 3, that becomes 2. And then getting the value of the z term here. So our z term here is 6 root, di ba? So x to the power of, so that's 3 all over 6. So second term is minus 6 over 2, that's 3. Then that's square, di ba? Then 6 roots, so 2 all over 6 minus 6 ln of, oops, ln of 6 root of x plus 1 plus c. So since the expressions can be simplified even further, So 3 over 6, that's 1 half. So that's 2 square root of x. 2 over 6, that's 1/3. So 3 cube root of x minus 6 ln of 6 root of x plus 1 plus c. So this one is your final answer. So complicated, no? So I think the tip here is um, for you to be able to understand that the kaning mga process sa integration is murag kuan siya kanang more of a trial and error method siya. So dili siya in one go. So napa din siya isa ka term day. Nalimtan ako og integrate ang 6 plus 6z day. Kuha nga nig plus 6z. So ato lang siyang i-insert dire. So na dire so plus 6 root of x ana. Okay, so if we try to verify this one in the symbol lab, so my answer is different from symbol lab. Okay, ang gigamit na technique is line sad. Okay, so do you have questions or clarifications? Okay, so I think there's no question. So again, just try to verify for yourself the equations that we have solved today. So compare it with the symbol lab, and you can also try a different method in the z-sub if it leads to a simpler expression. So if not, so most likely ang katong gi-present karon is the simplest method na, or the simplest way to, I mean the way to the simpler equation. All right, so if you have no more questions, so I'll be posting later the problem set. So the deadline siguro for the problem set will be kuan lang siguro next Monday na. Okay, murag this one is a difficult kuan naman siya topic. So I'll give you more time for these topics. But again, I'll be discussing the next advanced technique kuan next week yapon. Okay, so if you don't have questions, so see you next week. So I'll just announce when ta mag-meet, Tuesday ba or Thursday. Okay, so if you don't have questions, so you may be dismissed. So thank you so much.